So the last section in chapter 13 is graphing tangent. We just talked about graphing sine and cosine, the waves. These look completely different, as you can see from your notes. They're a bunch of repeated kind of squiggle lines. And in this chapter, not even in this course, it's only in trigonometry that you would do anything else with these graphs, but we're not going to be shifting them in any way, shape, or form. So we don't have to worry about that. So they're always going to intersect right at the origin. So you always know that it's going to cross right through the 0, 0. There's also these vertical asymptotes that I want you to draw in on the graph. Remember, an asymptote is a line that the graph is going to get closer and closer to, but never ever touch. And these also repeat at equal intervals. So these lines, the graph kind of hugs up against it. And on tangent, we do need to label them on our graph, and I'll show you how to do that. So they're always going to be evenly spaced, and then those tangent curves fit exactly in between them. All right, so here is the formula. There may or may not be a number in front of tangent. For this course, we're not going to worry about it. Just kind of ignore it for now. We are going to be looking at the positive and negative aspect of it, but the steepness of the curve we're not going to deal with in this chapter. We have a different variable there. With sine and cosine, we have a b. With tangent, we have a k. K is the number of cycles from 0 to pi instead of 0 to 2 pi like sine and cosine. So I will put this one up here as well on the board. That will stay up here. So again, the period is the length of one cycle, just like we had with sine and cosine. And we're going to try graphing this equation right here. All right, so y equals tan 6 theta. So we know it's going to cross through the origin. We have to figure out how long the period is, because we know the k value is 6, and this formula right here says that we should take pi over our k value, which is 6. So one cycle is pi over 6 units. So let's put down our asymptotes first. It tends to be easier if we kind of draw a framework for it to fit into. Now this length right here has to be repeated. We're going to draw at least 3 tangent cycles whenever you graph. So this right here has to be transferred so that you have another one the same exact width. So we're just kind of eyeballing this. So we always draw in the asymptotes first. Now when it's positive, the curve is, think of it having a positive slope. It's going to be going up and to the right. So it's always going to start in the middle. It's going to curve up this way. It's kind of like half of a parabola, it looks like. And then it's half of a parabola going down the other way. And then right in between those two, we'll go up, curve down, and right in between these two, up, and curve down. So the drawing of it typically isn't what kids say is the difficult part. The more difficult part is figuring out what do we label everything. So the period, pi over 6, is the length from here to here. That is pi over 6 units. So if we have 0, 0 in the middle, how far is just half of that? How much is half of pi over 6? If we had the fraction 1/6 and we wanted to cut it in half, what would it be? 1/12. So this right here is pi over 12. Now each of these little marks, this one, this one, this one, are all pi over 12. So the next one's going to be 2 pi over 12, which simplifies to be pi over 6. And 3 pi over 12 simplifies to be 3 pi over 12 is pi over 4. And I do want you to simplify them. So if the first time around you just want to write pi over 12, 2 pi over 12, 3 pi over 12, and then tell me what they are simplified underneath them, that's totally fine. And then these just get mirrored negative on the other side. So negative pi over 12, negative pi over 6, and negative pi over 4. So we need to label the asymptotes. We also need to label the points where it crosses the x-axis. So we'll do a couple more practice so that you see the pattern here. Questions yet? All right. This one. Negative 3 tan 1/2 theta. So let's graph it first. It's always good to just draw some asymptotes here. So we've got a framework to build in. Okay, now this equation has a negative on the front of it, so how is that going to change things? The curves are going to come down, and then we'll repeat that. And now I just need to label. Again, remember this 3 we are ignoring for the purposes of this class and this chapter. This is our k value. And remember that period is pi over k. So the period would be pi over 1/2, which would really be what do we do when we divide by fractions? What do we have to do to this 1/2? We have to flip it, so it's really pi times 2 over 1, which is 2 pi. So that is the length from here to here is 2 pi. So what is the red mark on the right going to be? If from red to red is 2 pi, from 0 to the red mark is pi. This would be negative pi, because if you added pi and pi together, you get 2 pi. So that's the length of the whole period, the whole cycle. So if this is pi, what's the blue line? 2 pi. This is 3 pi. Same thing mirrored over here. Questions on that? All right, so let's try coming up with this. The equation of the tangent graph, we have the period of 4 pi. So we have our equation, period equals pi over k. 4 pi goes where? Yep. So we've got 4 pi equals pi over k. How do we solve for k? Multiply by k. Now we have 4 pi k equals pi. How do you get k by itself? divide by 4 pi, what happens? Pi's cancel out and we're left with what? 1/4. So that's all we need in order to write an equation for tan. Okay, they didn't tell us the slope of whether it's going up or down, so we always assume it's positive. So we have tan. We just figured out the k value is 1/4, and we put a theta or an x on the end, and that's all they want. So if they give you the period, you just solve for k and put k in the equation. That's it. Questions before the last one? All right. Now, if they give you a picture like this one, all you have to do is figure out how long the period is and do exactly what we did before. So how long is the period? How long is it from here all the way over to here? 4 pi. Now, we just did one for 4 pi in the previous one, correct? So we put 4 pi here. We solved for it, and we got k equals 1/4. Now, what's different about this graph, though? It's negative. It's going down each time. So that's going to make the equation y equals Any questions?